Hello and welcome everyone to today's cloud coaching session. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. Thanks so much for joining us. Today we're excited to explore the Oracle Autonomous Database features for supporting application development across cloud services. We'll also be recording the session and the link to the recording will be sent to you via email in the next couple of days. If you have any questions during the webinar, we've set up a channel in our developer public Slack called Cloud Coaching North America that you can access at the QR code here or at bit.ly/odevrel_Slack. Once you're in, you'll land in the general channel, and from there you can search for the webinar channel. We'll also be checking the Zoom chat and Zoom Q&A areas throughout the webinar, and we'll open up for live Q&A after the demo. Today's webcast will be presented by Master Principal Cloud Architects Derek Cameron and Stephen Nichols. So without further ado, I will hand it over to Derek.
Thank you, Tara, and welcome to our presentation today. So this is going to be very slide-like today. Steve and I are going to be walking through a lot of code. We have also a GitHub repository. As we go through all this code, you don't have to worry about writing everything down, taking screenshots, etc. Tara will be sharing the recording and as well as sharing the GitHub link to the code that we're going to be walking through today. This is really a follow-on and to some presentations we did in the past. There was one on DBMS Cloud, and there was one on autonomous database for legacy developers. So there's a couple of things we'll be covering today that overlap with that, but there's a lot of net new stuff. And what I wanted to do is we've been working in the Code Innovate program with a lot of customers with services that interact with the database that are using our APIs and some of the new features. And so we thought we'd do a presentation today focused purely on the interaction of data sources, things like object storage, data in other data sources that interact with the database that are in the cloud. So let's get started. I do have some use cases here. I realize I've got a lot of material. And so when you download the presentation, go take a look at the use cases here. We pulled them out of our repository, our Code Innovate repository. I counted around 55 we've done in the last couple of years that involve autonomous database and other services, things like working and extending EBS, things like interchanging data with EPM, use cases, many of them that involve customers that have spreadsheet applications that want to move to the cloud, but still need to maintain some of that data in spreadsheets. And how do we work with spreadsheets, work with EBS, you work with EPM and those other databases, those other applications, and still process and leverage all the great things with the autonomous database. So take a look at the use cases. You'll see some examples there. Maybe some of these things look familiar to you. So I'm a 30-year kind of veteran of the database. I mean, what we used to do is just get the data in the database. After that, all is good. That is actually still good advice. But the reality is we have applications, we have other applications. We do a lot of data exchange, and it's very common in the cloud as well, services we want to leverage. And so we need to be able to exchange that data, work with that data without, consolidating it in the database. And that's the only place we work. So, we used to script the data, put it in an Oracle directory on the Oracle server. That requires permissions. A lot of time we don't have those permissions. So we have some other choices now with object storage. REST APIs, still a good option. I don't want to sort of suggest you don't use those anymore. The REST API support on the database and other cloud services continues to expand. It's a great option, but it does have some limitations. These are just some alternative choices, get you thinking. Database links as well is popular, but there's certain things you need for that. It's, a privileged user, it needs network connectivity. If we look at some of the limitations there, REST APIs, if you have multi-million row tables, pulling data with REST is kind of slow, it's complicated. So we've got some other choices now, processing end user Excel CSV files as well. We have users dropping files into common storage areas for processing. We want to be able to, give the end user access to those locations either directly or through things like Apex. We use Apex a lot with our use cases. But if you can use database links, great, except you need a lot of upfront peer-to-peer configuration. You need to deal with wallets or TLS configuration. Database link support has been expanding. I wouldn't say don't use them, but we have some other choices that don't require all those permissions, right? So new options, we're going to go back into object storage configuration, look at what we're going to process, how to process files there. Brand new persistent pipes. I'll talk about persistent pipes. Those were used, have been around for a long time, but it was only for inter-session communications within one database. Persistent pipes now allow you to put those messages out on object storage. Massive opportunity for re-architecting some of your applications to take advantage of that. Cloud links, brand new. Cloud links are basically kind of a pub-sub publication subscription model approach to things like database links. You can publish a table out for the community, private or public, and allow access without having to set up database links, which require, of course, wallets and TLS and ports open and all of that. So let's get started. So I have to actually cover credentials before we get into all the material we're going to be covering today. And the reason is you can't really do anything outside the database without creating a credential. And the reason I want to cover it as well is we have different credential types, and it can be a little confusing. We haven't really dedicated a presentation to this, but I wanted to cover it today. So when you create a credential and you want to have the database to talk to some other service, things like object storage, you need the credentials for that. And so when you do that, you create a credential here, credential name, the username, a password. We see two others in here, and we'll be covering this in more detail in a future webcast in September. Steve will be running one on the SDK for OCI, and it requires a different version of that credential. I will not cover that today. I'm just touching on that. When you look at these, like, well, what are the differences? This one's for the OCI SDK. We'll cover that, I said, in September. And then this other one, it's another version, same command, it's another version, and it is used to access things like AWS credentials, right? So these are pretty important. How do these relate to my end user? So if I go into, here's my end user. I'm a local user. Whether it's local or federated, doesn't matter. You need to set up for the database an auth token. Perhaps not a great name. I call it API token. It's actually just a credential. You generate that token in the auth tokens. You generate that token, and when you go in here, it returns a cryptic password. You'll never see it again. So if you forget it, you'll have to just regenerate that token. You create with the IDCS, your OCI username, and then the password will be that credential, that token that gets generated in the OCI console in your user ID. You go into your user, create an auth token, pick up that credential, go into the database here, issue that's PL SQL, create the credential, enter the token, and you're good to go. We also have one for GitHub. Okay, I did that back in the previous presentation. I got one for the GitHub repository as well. Now you might ask, well, okay, I got an auth. What is this API key? Well, if you're not in the database, you're maybe doing the OCI CLI, or maybe you are using Python or some service outside the database. You need a PEM key, right? You need a PEM key, public, private. It has a tenancy hosted, has a fingerprint. You set that up. If you're going to do an OCI CLI, you need that config file. Well, that API key is used in that. And so that's a little bit different. I think of it this way, is that these are used for internal database authentication to outside services. the API keys are used for intercommunication to authenticate between different services within or outside the database. So just keep that in mind. So let's move on to, let's look at some code. So I've got a database running here. I've got a demo schema. I've got my admin schema. I have some data in here. I've got the admin, and I've got another database. Steve's lent me his database. Thank you, Steve. And it's got an admin user ID and a user password. It's the DGC, my initials, in Steve's database, and my demo schema in my database. You know, best practice is not to put data into the admin account. So I usually create a user schema for that. Now let's take a look at a very basic thing. I covered this on the last webinar, and let's just look at what files are in my bucket. And so you can query this just like a table. And so here we have sales, 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 and sales extended Parquet. So I want to query these files. I need to create an external table. Let's take a look at where they are. I'll go in here, go into storage, go into object storage. And I've got a sales bucket. And here are those files. You saw them queried in PL SQL, right? You saw them queried. There they are there. And so I'm going to create an external table to query these files here. And I'm going to do a pattern match because I don't want to query this one. It's a completely different format. And so I'm going to create a pattern that picks up those files. It could be a wildcard, could be star, anything. Great thing is you could say to a customer, just drop your file in the bucket, and I don't care what name it is, as long as it's structured properly, it will be included in the query. And so let's do that right now. We're going to create an external table on top of these files here. We did that again. We did that in a previous presentation. A kind of important thing to note here, there's the wildcarding sales, 1 star. I do have to specify the structure. The structure is not in there's headings. Yes, there's headings, but they're not structure in there. When we go to Parquet, my new best friend, Parquet, the structure is in the file. You do not need to do any of this. And if you had 200, 300, 500 columns, it gets really tired to specify a file like that. You got a Parquet file. It's all part of the, so there it is. I created that. Let's take a look at that, refresh. There's my external table. I want to look at the data. Let's take a look at that. It's querying the files now, all of them, 1, 2, 3, 4, 5, 6, 7, 8, 9. You got 10 files, 100 files. It'll go right across all those files, pull the data, pretty performant. So, the next thing I want to do is compare it to Parquet, and Parquet has the structure, as I said, embedded right in the file. And so when you create an external table, well, it's just going to pick it up. You don't have to do any of that typing. Let's do that on top of that Parquet file now. And by the way, there's a really interesting open source utility for looking at Parquet files. I've taken it out of this presentation because I had to cut down the material, but it's Park, P-A-R-Q. I have it as a command line on my Linux desktop, and I can look at the file, I can look at the headers, I can look at the definition. I'd encourage you to install that because then you can look at it right on your desktop. So yeah, so go in here. I'm going to copy this, and let's look at the Parquet version. Here it is here. You'll notice it's the sales extended Parquet. The type is Parquet. You don't need to specify all of this stuff here. Let's execute that. It's creating an external table. It's read the metadata. Let's refresh that. There's the Parquet file, and we can immediately start querying it. Now I'm going to do a couple of other things because I want to demonstrate just how efficient Parquet file access is. And I am actually taking this from a blog from my good friend Marty Goober in development. He did a blog on this, and that blog has really drove me to put this in this webinar. Is like boy, this is really slick. Let me show that in my webinar, but there's a blog on it. And again, the link will be in our presentation material post-event. So there it is there. Now I'm going to do another thing because I want to demonstrate the storage efficiency and query efficiency of the data. I'm going to copy it. Let me just query refresh here. I've got the Parquet file. I copied the Parquet file to a local table. Then I'm going to copy the local table back to a CSV file on the, I'm going to copy, well, no, I'm going to copy data actually from here into here. I've just created the table here. Let me copy the data into that table. 900,000 rows. It's going to populate this table here. It hadn't got any data. I just defined it. So now I've copied the data from Parquet into extended. And now, stay with me here, folks, because there's a reason for all of this. I am going to copy the data back to the sales extended CSV. Now, why are you doing that? You copy it from object storage into a table, and then from a table back to object storage. Well, I'm copying it back to a CSV version to compare with the Parquet version. So let's do that. And let's take a look at that in object storage. So again, you notice DBMS copy data allows you to copy data back and forth bidirectional. Let's go back to my sales directory, object storage bucket. There it is there. Let's take a look at that. 8 megabytes Parquet, 63 megabytes CSV. All right. I'm going to rename this because that file name changes. It appends the timestamp onto it. And when it does that, I would have to redefine my external table. I have not done that. I just renamed the file here. So now I can query that data on my external table in the database. Let's do that. Create external table, copy. And again, there's reason for all these steps, and that is, there it is there, sales extended CSV, external table. There it is there, right click, refresh. Now I've got the external table on the CSV file, the Parquet version. This is 63 megs. This is 8 megs. This is local. It's local. And so, well, why are you doing this again? Well, it's not just all about the storage. Storage is cheap. When we go query the data in this file here, whether you query one column or the entire column, all the columns, it is going to do IO. It's going to read the entire file, and it could be a massive file. The Parquet, if I say select prod ID, it actually selectively reads just the data in that column. The IO is dramatically different. Let's look at that. Create table. I'm going to create local tables of this now. This one here, let's look at it. Local table PQ1 as select prod ID, one column from the sales extended CSV, 78 megabytes. I'm going to create, if I select all of the columns from sales extended CSV, 84, almost the same. If I select prod ID, same as this one, from the Parquet file, less than 5 megabytes. It's fast, it's efficient, and if you have choices about storing object storage files, Parquet is definitely the way to go. And you can see this in the performance monitor when you go into the database. So if I execute these, I'm going to just execute them sequentially, 1, 2, 3. And I'll go back to, as this is running, we'll create those, go back in here. Where is that, Derek? It is, go to Oracle database, autonomous database. We're going to go into the database that I have running here. We're going to go into the Performance Hub, and we'll see those in here. You can see the different timings with the different sessions. I won't go into each and every one of these. We've got the Parquet version, we've got the single column version, and we've got the multiple column versions. The I/O I actually captured and commented on in SQL Developer here, 7884 4.9. So I'd encourage you can go into Performance Monitor. There's lots and lots of information to measure the efficiency of that, but it's really super, super efficient. So that's enough on the Parquet files. Let's move on to Cloud Links. Cloud Links are really, as I said, a publish, subscribe approach to making tables and schemas available to other databases. And super interesting. It's a V1 version. There is quite a few limitations on this. If you drop the table and recreate it, you have to recreate the cloud link. Just an FYI on that. There is a link to kind of the notes on this, but it certainly is an intriguing approach to sharing data between databases. They can be public or private. You can be very selective. They can be tenancy-wide. They can be region-wide. They can scope in different areas. And so, yeah. So let's take a look at that. Let's look at the permissions first of all. Copy. I'm going to go into admin here. And you got to grant execute on DBMS Cloud Link to demo. Let's do that. I'm admin to do that, right? I did the grant there. And I also need to give the scope. Like I need to say, well, demo can do anything? No, demo can't do anything. What is the scope that I'm going to grant? There's a grant register here. I'm going to do it for my own purposes, tenancy-wide. I'm granting a tenancy-wide capability for demo. I'm up here in admin doing this for demo here to be able to make available this table here. And of course, it could even be the external table. So what you're really doing is through the database granting privileges potentially to data even outside the database, because external tables are to every other service no different. So there's, I've done the register. I'm going to do a revoke because I realized when I was redoing this is that I do need to, if I try to re-grant this, it's going to come up with an error. Let me revoke the one I'd done while I was testing this previously. And now let me register it. Again, Cloud Links, I'm registering sales extended. I'm registering and making it available. I'm not actually querying it. I'm making it available. I'm going to give it a namespace DGCADW. The table name is sales extended. And I've got a comment here, my tenancy. I'm in demo. Let's do that. Oops. I'm going to hit the begin. I've made it available. Whoops. And let's take a look. We're going to go into the target schema now. So I've registered it. Who can see it? I've made it. I'm going to go into Steve's database now. And the first thing is I need to, I'm in Steve's database. I created a user called DGC. So demo published, DGC is going to subscribe in another database. So let's look at that. So I've granted access to DGC. And let's just look at those. Like, first of all, well, how do you even know you've got subscriptions? Like, how do I even know what's available? Well, you execute a query to do that. And here it is here. It comes out as a JSON object. The name is sales extended. There's the namespace. There's the description. That's what's been published. And now admin says, hey, let me find some links out there. What's out there? Well, this is what's out there. And now, now let's go into DGC. And there it is there. I'm DGC. I have rights to look at that link. I can now use it. Now I'm doing a select count star from the database, the table in demo in my other database. Really interesting. No database links required. It's a pub sub sort of model. All you got to do is publish it and subscribe to it in your remote sources. And they can be private, as I said. Very interesting. This is kind of getting around the whole database link thing. And let's just look at the limitations. Copy. I'll just go back to here and close that here. I just want to sort of alert you to the fact that there are some limitations, notes on cloud links, things like there's a limit of maximum of 4 open database links per session. If cache is enabled, it'll hit cache instead. You have to think a little bit about this. If you drop and recreate a table that was registered, you need to re-register the table. So just an FYI on that, just take a look at that. So let's move on to the last topic before I give it over to Steve, which is persistent pipes. Well, persistent pipes were originally, they've been around in the database for years, maybe decades, like probably 15 years or more. They were originally intended for session 1 to be able to talk to session 2 in the same database, a bit like chatter between 2 friends. And it's in SGA, important concept here. It's actually in database memory. And so fine, so if the database shuts down, by the way, all the messages are gone too. Persistent pipes, new in Autonomous Database, allows you to actually push these messages now out to object storage. And so first things first, you got to grant execute on DBMS pipe. So again, let's look at the permissions. We're going here. I'm going to be admin. I'm admin. Let's do the grants. I grant execute and DBMS pipe to demo. I'm back in my database again. And this is really important too, because I ran right into this. Now I'm demo. You need to execute this every time the database restarts. And since we have our databases in our demo tenancy shutting down on a schedule every night, this blew up on me the next day. And I'm like, why is that? Well, you need to reestablish the pipe when the database restarts. Just a heads up on that. So as part of a database restart, you could actually script this as an auto execute thing. So let's publish the message. This is so interesting. I've never heard of these things before. Copy. I'm going to publish a message. Let's look at the code for that. Now you'll know why we put the code in GitHub. You're not going to copy this on a webinar, are you? So we have some declarations. It could be, of course, a stored procedure that does that. You pack the message. I put some values in it, and I send the message through the pipe, the credential name. I've set the credential, and there's the location. And then let's do that. Sending the pipe, let's go to object storage. I have it in a different location. Let me go to Oracle database, Autonomous Database. Go to, no, not there, Derek. It is in storage. The message is in object storage, and I created a pipe message. There it is there. Download that message. You'll find it is binary formatted. It is not readable. So let's consume that message. I'm going to go here and I'm going to read the message, and I am going to write it to a database table. So I'm going to copy that. Control-V. I'm going to, now I'm reading. So you're unpacking the message, unpack message. There it is, and insert it. It's reading the message. It's inserting it into sales extended. And let's look at, there it is there. This was just added. These are the messages right here. And so, yeah, you can now exchange data with multiple databases. The important thing is whether I reread that back into the same database or some other database reads that message, it does an automatic removal from object storage. I read that message. Now that I've read the message is automatically purged and deleted. Let's go back into pipe, and there it is, it's gone. So whether or not I read it or some other database read it, that subscription, the retrieval of that message and processing. So you can imagine you can set up a queuing system where you publish messages, they're consumed by other subscribers, other folks that have access to that, and you can transact. This can be a transaction, a cross database transaction. So I've got another example with Steve's database. I don't think it's necessary to actually show you that code. I can publish it. I can pick it up from Steve's database, some other database, as long as it's got permissions. It does need permissions to the pipe. And you also need to do that, establish that pipe in the target database as well. Okay. But once you've done that, you can consume messages on this, on this pipe. Super interesting. Think about what kind of applications that might use that. So with that, Steve, I'm going to stop sharing and I'm going to hand it over to Steve to cover a much more comprehensive example of something we did for a customer.
Great.
Take it away, Steve.
Thank you, Derek. Let me share my screen here. And as I share my screen, I'm going to give a high-level overview of the use case. So in general, the use case, this is one specific use case that we helped at a customer recently. The use case was around data being loaded into an object storage bucket daily or nightly. The data was in a CSV format, but it was also zipped up. So it was a zip file sitting in object storage within a bucket. And they needed a process that would take that zip file, open it up, read the CSV file, do some basic data transformations to that file, and then load it into a table within the autonomous database. Once the data was loaded into the autonomous database, then the users could access that information via Apex, using an Apex workspace and screens. So what I'm going to walk through is the PLSQL code that I used, or that I helped him write, to be able to read that file, process it, load it, transform the data, and then manage that file once it's been picked up. So you'll see here I'm in object storage. I have a bucket called webinar. I have 3 folders within that bucket, and you'll see the meaning or the use of these folders here in a moment. One's called CSV temp. One is an inbox. So that's the inbox where the file gets placed into on their nightly process. And then we also have a folder called processed, which will place the files that have been processed into that bucket for historical purposes. So that's on the object storage side. If you look at the actual PLSQL that's going to be run, it's not that long, and I'll go through it in detail here. The main point of this procedure is to show how you can interact with object storage pretty easily. If you remember earlier, Derek talked about credentials. So we're using a credential, an authorization token credential, to be able to talk to object storage, that bucket and the folders within that bucket. The PLSQL has some constants in here. As you know, each bucket sits within an object storage region, namespace, and so forth. So we define that up front as a variable. And then the rest of them are just variables that I use throughout the processing. So I'll walk through this in detail and then I'll execute it and show you the results. So basically, we start off with using a DBMS lob create temporary. And what this function does is, if you remember, I have to read a zip file. I have to unzip it and then take the contents of that zip file, process it. And that's where I use the lob comes in. So I have to take the contents of the CSV file, which was inside the zip file, place it into a temporary storage variable, which is a blob, a binary large object, work with it, and then when I'm done with it, I close it out. So I create a temporary one, and then and if you look up at the top here, I have a cursor. So I think Derek showed this earlier in his part of the presentation. We're using DBMS Cloud list objects. I'm using credential, and then I'm using a URL and bucket. And I'm basically issuing a select statement against object storage to return all files that match a where clause of .zip. So give me all the zip files within my bucket so that I know that they're there, and I'll process them. Once I get that list of files, I then process it. So I start off with the outer for loop. So every zip file that's inside my bucket, I'm going to take that zip file, and then at this point, I just have a list of files. I now want to get the actual file itself, the actual contents of the file. So I use a DBMS Cloud get object. Once I get that object, now I need to unzip it. And this is where I switch from a DBMS Cloud function to an Apex. So here's an Apex zip function. And if you remember, if you're using an autonomous database, every autonomous database comes with an Apex environment already stood up and configured for you. So these Apex utilities are available for you to leverage. And so I'm using the Apex zip get files. So in theory, the zip file could have multiple CSV files in it. So I get the zip files or the CSV files out of the zip file. And then for every CSV file that's inside that zip file, I want to process it. And so that's what the inner for loop is for. In my example, I have one zip file with one CSV file inside of it. So it's a one-to-one, but in theory, you could have more than one. And then I need to take that, the contents of that file and store it into my lob that I created earlier, my temporary lob. So I take the contents of that CSV file, I place it into a lob, a large object, and then because I'm using the DBMS Cloud copy data function, which is a good function for taking CSV files and loading them into a table, the expectation is that data is going to be sitting in a object storage bucket as an object, which is CSV. So I have to take the contents of that CSV file that I had just unpacked or unzipped, and I place it into the DBMS Cloud put object. So I use the DBMS Cloud put object to store it in my object storage bucket. And that's where that CSV temp folder came in. It's just a temporary folder to store this file while I process it. So once I place it there, I then execute a basic command, which is truncating a table that I'm going to load into, a stage table. But then the DBMS Cloud copy data is what's going to do most of the heavy lifting for me. And again, you'll see the credential name. This is the credential that I'm using. I'm loading that into a table name called audit record stage. And CD just means copy data. I have different versions of this. This is the URL of the CSV file that I just placed in the object storage using the put object. And then this is the format of the file that I'm processing. And this is where this is the important part of this data copy function. If you look at my data file, and I can show you that, you can see that it's a CSV commented file. It has many rows. There's about 20,000 rows in this file. But the interesting part is you'll see that this data, this is actually one row right here. But this one row has a column or a field of data that has line feeds in it, which when you look at it in a native notepad, it looks like multiple lines. But in theory, that's one row, and that value is actually one value that has line feeds in it. So another way to look at it is if you look at it in the CSV format, you can see what I mean. Like Excel is able to interpret that as one field with line feeds in it. And we want to make sure that we load the data the same way as well. And so the reason I go into that detail is when you look at the type, you want to say CSV with embedded. And what that means is that it's a comma delimited file. It's using quotes, but then the values within those quotes can have embedded line feeds. And we want the data copy to preserve those and copy them into the column correctly. So once the DBMS Cloud copy data is done, I then do some updates to it. This is just some basic update statement against the stage table. I'm taking one value and splitting it out into many and saving it into additional columns within the table. Once the update is done, I grab the update count because I want to preserve that for historical purposes. I capture that for some audit trail that you'll see here in a minute. And once I'm done with the basic transformation of the data, I then insert it into the final table, which can already have records into it from the days before load. And this is really just inserting all the records from stage into the final audit records. Once that's done, I grab how many rows I inserted in. And then once I've committed my changes, I want to delete my CSV temp file. So if you remember, I took that CSV out of a zip file. So I unzipped it, grabbed it, I stored it in object storage temporarily. I now know that it's loaded. So now I'm going to delete that object out. So I'm using the DBM's Cloud delete object. And then lastly, and this is kind of an optional thing, but it's nice. You'll see how this looks when I run it. I also save the information about that file that I loaded and the actual data itself. So I'm loading into a audit file or table. I'm loading in the file name, the zip file name, because you can have multiple zip files. You can have multiple CSV files inside of those zip files. So I'm saving the zip file name, the CSV file name. I'm actually saving the contents as well into a blob, a large binary object. I'm also saving off the number of rows that I've inserted in, and also the number of rows that I updated based on those upper insert and update commands that I ran. And so I save that off. And once I've finished processing that, all the files within that zip file, the closed loop ends. And then I don't want to pick that file up and load it again. So at the end, I use DBMS Cloud move object. And what that does, it's moving the object from one folder to another in my case. So it's moving it from the zip inbox to the zip process folder within object storage inside my bucket. So I'm using the DBMS Cloud move object to move it into a process. So I don't want to delete it, but I do want to move it out of the inbox so I don't process it again. And then once it's moved, the last thing I do is I free my large object that I use to store my contents of my CSV files, and then the procedure is done. So if I run this procedure, I'm just using the SQL Developer Run feature here, but it'll run. It takes a few seconds to run. I apologize, this font's a little small, but this captures the DBMS system output stuff that gets captured. I loaded, you can see I updated 231 records. I loaded 20,102 records, and it took approximately 3 to 4 seconds to run. And then what that looks like is if you go over to the actual tables, these are the audit records. If you look at the data, you can see that the data was loaded. It was also processed. And also, and this is where I load the CSV file into the table as well. So this is the data was loaded. This is the file that I loaded. This is a CSV file inside that zip file that I processed. This is the contents of the zip file, or the CSV file, sorry. These are the number of rows I inserted and these number of rows I updated. And if you actually look at this, it's not a large file, so you'll see it here in a moment. This is actually the contents of the CSV file that I processed. This is the same one that I was looking at in Notepad, the same one I was looking at in Excel. And then lastly, now that everything's processed, if you go back and look at object storage, if you remember, it was originally in my inbox. If I do a refresh on my object storage bucket, you can see that nothing's in the inbox now, and that the file was now moved to the processed. So, essentially, I was able to read CSV or zip files, unzip them, process the data inside of them, save off that data and information that I processed, and move the file into a different folder within that bucket. So that's really it for my example. I just wanted to show you a comprehensive way of leveraging PLSQL, but interacting with the object storage service to be able to process files. So at this point, I believe we're done with the demo part of our presentation. And at this point, I do see a couple questions. I think we'll circle back to them at the end. But I want to take a minute to share with you the Code Innovate program. This is a team that Derek and I are both on. And some of you may be familiar with this, some of you may not be. But what the Code Innovate program essentially is we like to use the analogy of Legoland. So if you've ever gone to Legoland, taken your kids to Legoland, you know, the idea is that you go to a master builder class. You go in with an idea of what you want to build. You're given some parts, some pieces, but you're not sure how to get to the end. But by the end of the class, you work with a master builder, someone who knows how to build that, can guide you on how to build that. You're building it yourself, but they're helping you build it. And at the end of your time spent at Legoland, you have a result. In this case, it's a penguin. Code Innovate is very similar to that. It's a virtual event. We call it a 5 half-day event that allows you to kind of jumpstart your cloud development. It allows you to be hands-on. The key with the Code Innovate is it's you all, the customers that are doing the hands on the keyboard building it, and the Oracle engineers are guiding you along the way. It helps, you know, us to share best practices. It shares our knowledge with you. And the key is that we ask you for use cases. Like, we don't come to you and say, you know, this is what we want you to try out. We say, hey, what do you want to try out? What do you want to, you know, what's something you want to build in our cloud? And then we'll walk through that with you. Another key takeaway is that it's no cost to you other than the cloud services that you leverage in your tenancy. You know, and again, so the whole Code Innovate experience begins with use cases. You share with us the use cases you want. We build an event around that. We build teams, multiple teams in many cases. Our engineer works with your team to build out a use case. We spend about 4 hours a day for 5 days straight. And at the end, we have what's called a first pass prototype or a minimum viable product. And you get experience and knowledge on working in the Oracle Cloud. And so I believe Tara and others will share this with you, but this is an email that you can contact us with, the codeinnovate_us_group@oracle.com. You can also enter your information into Zoom as well. But we wanted to share with you this offering that Oracle has for jumpstarting your cloud development.
All right. Looks like we've covered everything. So thank you everyone so much again for joining us here today, and we hope to see you at the next one.
Thank you. Have a good day.
Thanks.
Thanks.